This video is on an introduction to thermochem, discussing things like energy, heat, what thermochem is, and then the two types of reactions that we will study, which are called endo and exothermic. Okay, so to start with, thermochem obviously revolves around heat and energy, and so there's a few words we need to define before moving any further into this topic. So the first one is, what is energy? It's kind of a challenging word to define. Okay, so its technical definition is it's the capacity to do work or to supply heat. So technically, this is kind of a two-part definition, and there are two classes that cover this idea of energy changes. Okay, so the first part of the definition, the capacity to do work, that's a physics discussion. So we will not be talking about work in this class, but if you took physics, you would. What we will talk about in chemistry is the supplying of heat. Okay, so what is thermochemistry? It's the study of energy changes in reactions. So we've been talking about chemical reactions for a very long time. At this point, what we're talking about now is what is the energy flow in a chemical reaction, and we'll be a little more specific about that later. Okay, so why are there energy changes in reactions is definitely a question that's asked, and that is because all chemical bonds have stored energy. And when chemical bonds are broken or formed, there are energy changes. So that energy is referred to as chemical potential energy, and it's just the energy that's stored in a chemical bond, like an ionic bond or a covalent bond. Oops. Okay. And then the last term to define is heat, which is also kind of a challenging term to put a definition to. Before we put a definition with the word heat, we're going to talk about that in chemistry. Heat is represented by the variable lowercase q. So heat is going to be lowercase q for us. And we're going to define heat as the energy transfer due to a difference in temperature. And then one other thing, that heat will always flow from the hot object to the cold object until temperatures are equal. So we're going to be doing a lot of discussion on heat, or Q. We're also going to be doing a lot of discussion on temperature in this chapter of thermochem. Okay, so moving on to a little bit more specific ideas. Before we can define endo and exo, we have a couple other things we have to define first. So I'm going to do an example. So let's say that we have a beaker and it has water in it, and we put some sodium chloride into the beaker. I also have a thermometer, because anytime we're studying heat, we're going to need a thermometer. Okay, so there are two words in thermochem that are really important that we define and that we understand. And the first word is the system, and the second word is the surroundings. Okay, so the word system is technically defined as the thing that we're studying. It's a pretty vague definition. But here's the important part. For us, the system will always be the chemical reaction. And it's important here to note that, and this will come back up later, that we always use the system's perspective when discussing thermochem ideas. That doesn't make a whole lot of sense to you right now, but it will shortly. So in this case, the reaction, I mean, we've talked about this a little bit, that, the water here is really not reacting. It's just the sodium chloride that's going to undergo an ionization reaction. So in this case, the system would be just the ionization of sodium chloride. That's it. So the system is the chemical reaction, period, all the time. So the surroundings then are everything else. That's also very vague. Okay, but what we mean by that is, like in this case, the surroundings would be the beaker, the thermometer, the water, which is sometimes hard for students to understand that the water is part of the surroundings. And then I want to add on to this that you or us, okay, we would be part of the surroundings. Imagine holding this beaker. You're not the reaction, so your point of view is going to be different than what's happening in the reaction itself, okay? And that's going to be really important. Okay, so there's a major goal of thermo. And that is to study the heat flow, I guess is a good word, between the system and the surroundings. And this flow of heat revolves around something that I'm going to call the first law of thermodynamics. Which says that heat or energy is conserved. It's not lost or gained. It's only transferred between different species. So what does that mean? So with our new terminology here, system and surroundings, what we can say is that if the system loses heat, then the surroundings must gain it. And vice versa, of course. We could flip that statement around and say that if the surroundings gain heat, if the system gains heat, then the surroundings had to release it or had to lose it, okay? That brings up an important thing that I end up writing a lot, which is we just said that heat is represented by the variable Q. And so you'll see me often write that Q of the system is equal to negative Q of the surroundings. Now, heat is not negative. That negative is only indicative of the flow of heat. So is heat leaving or going into something? So what this little equation means is that, if the Q of the system is increasing, then Q of the surroundings heat is decreasing, or vice versa. This negative here does not mean that the surroundings are always losing heat, okay? It's just saying that its sign would be opposite of the system. And that all goes back to this line right here, which is so important, right? What one loses, the other one gains, and that is the big idea in thermo. Okay, so from here, and let me say this one more time. We'll say heat flow is always from the the system's point of view. So I know we said that before up here somewhere. Yeah, with system. Okay, but that's important as we now define indo and exo. So we'll be able to put every reaction in thermochem into one of two categories. It's either an endothermic reaction or it's an exothermic reaction. So endothermic, you probably know that the prefix in means, into, all right? So in an endothermic reaction, the system or the reaction, right, gains heat, right, into. So the system gains heat. This is what we mean by from the system's perspective. We're classifying it as endo because the system is gaining the heat, which means that the surroundings have lost the heat. We can put a Q of the system here. It's gaining, okay, so it's going to be a positive value. And then this is something that we talk about all the time. So if you were holding a beaker in which an endothermic reaction took place, remember that you're part of the surroundings. So endothermic, the reaction is gaining heat. And it's gaining heat from the surroundings, which are you're part of. So you're losing the heat. So you're holding a beaker in which an endothermic reaction takes place. You're going to feel cold. Let's go over that one more time, right? You feel cold because in an endothermic reaction, the surroundings are losing the heat and the heat is going into the reaction. And I'm sure you can guess that an exothermic reaction is exactly the opposite. In an exothermic, the system loses the heat. The surroundings gain the heat. Q of the system in this case will be a negative value because heat is being released from the reaction. And then again, if you're holding a beaker in which an exothermic reaction occurs, the reaction is releasing heat to the surroundings, which is you're part of, so you would feel hot. Okay, you would feel an increase in temperature. So it's really important to be able to understand the distinction between endo and exo and what you would feel versus what the system and the surroundings are both doing. So there's a couple takeaway points from today, right? The takeaways are that the system is always the reaction, and we put everything in the system's point of view. Unfortunately, you will always be part of the surroundings, and so it's a little bit tricky to almost reverse that in your head to think that, well, what I'm feeling is not what the reaction is doing, it's what the surroundings are doing. And so that's a little bit tricky when we go to have this discussion about endo and exothermic reactions. So that's the intro to thermochem, and from here on out we get a little more specific into formulas and things of that nature. But that's your intro to system and surroundings and endo and exothermic reactions.